So I just want to check. I'm gonna go on YouTube now. Okay, now there is audio. Okay, it's cool. Just want to check.
It's real time.
Yeah. Go.
This guy is gonna do that in 2 minutes. It's a predictive model.
Yeah, I'll watch to you on the other one. I'll go to the other one.
Oh, okay. Okay, fine. Right. That was a great talk, actually. Many things that I recognize very interesting. I like the last part, which is data-driven, which is totally against KPIs, of course. It's hard to be creative where you only solve KPIs. By the way. Just a minute.
Please, can you read that?
Yeah. Too much processing required for that. Okay.
Just but if I zoom. Okay.
It's okay. I mean, I'm just in front of my company name. It's fine. I have to talk like that. So where do I enter that? Okay, there. So send them here. Okay. Thanks for being here. I tried to give a demo. Who wants a demo today? Nobody? If there is nobody raising his hand, I don't give a demo. I talk all the way. Okay, fine. I won't give it. So I'm here to talk about manual video by Kensu. I'll talk about what this Kensu, if it appears. I know that in title there were some mention of Kafka and Cassandra. I will just say that we are supported. If you're interested, I will give a few words about it though, but I would like to follow up with the previous talk in order to put some emphasis on the very specific points he told about regarding data science team, enterprise problems, and so on and so forth. So Kensu is our mission is to lift data science to the enterprise level. Kensu has been founded in 2015. Originally, we were named Data Fellas. I don't know if you know Data Fellas. It's a Belgian company that we created like in 2015, and we changed the name for some reasons. One of them is that because we shifted from a service company to a product company late 15. The product is named Adalog, ADALOG. And what we want to do, as I said, is to lift the data science to the enterprise level, which is, enterprise is not the, how to say, the funniest word in the world. But we want to stick with that in order to enable more data science around us. The founding team, so it's myself, Andy Petrella. So my name sounds like Italian. My father is Italian, but I can't really speak Italian. I talk Italian. I can a little bit. I can hear it. I can make my way with it, but not for a full talk. So I will continue in English if you don't mind. I'm a mathematician. I did some computer science as well, but I prefer to say that I'm a mathematician originally. It makes me weirder. And I work mainly in distributed computing since 2000. So I work with, I'm very graph freak. So I did computer science in math, doing graph theory in Liège, in Belgium, where they do analysis, which is totally different from what I wanted to do. Anyway, so I'm graph freak. I started with distributed computing from the art. I did geospatial. I don't know who is familiar with geospatial analysis. Who? Okay, not that long. Okay, no one. Yeah, geospatial is like, these fracking maps of terabytes of data picked by satellite, and all this crap I had to deal with from 2000s. Terabytes for me is like one image. So I had to create some, not really one image, a few images anyway. So I had to create some distributed computing frameworks at that time in order to deal with that. And in 2011, I discovered Spark, which was solving a lot of problems that I had, like my own APIs that were as much as crappier and as the other ones. So I started using Spark in 2011. I started writing about it in 2012, and now I'm writing a book with my buddy Xavier Todwar, another one that is prepper from San Francisco, about how to deal with Spark in Scala for production. So actually, it's a book about Scala, taking Spark as an example and how to go to production with it. Xavier Todwar, my buddy and co-founder of Kensu, is a physicist, and I'm a mathematician, and we kind of support each other. Is a man of genomics, so we do a lot of things with genomics. So he did also his own distributed computing framework in Perl. No, I'm kidding, just in C++ and then a Perl interface on top of it. And so, yeah, actually this is mainly the founding team. We were 2 until April this year. We are 11 now in the company. So we had our time to hire. But now we are at a good stage, I would say, but we still have some position open. I have guys in Lithuania, Russia, France, Belgium, and so don't be afraid because you're in Italy. I'm open to it, of course. Okay, so I'm going to go fast on the 4 next slides. 4, only 4, right? And then I will end with the demonstration. So we are a data science team minded. So that means that we are very focusing on the data science team problem. I'm not talking about data scientists, right? Which is, by the way, as it has been discovered by Stack Overflow. Who knows Stack Overflow? Everybody knows it, right? Okay, they do survey every year, right? And in 2015, they discover a new emerging group in their users, the data scientists, the way they call it, right? In 2015, so we are very at the beginning of the story. In 2016, they discovered that actually, I think it was 60% of them were still following Coursera courses. So you can think that actually, most of them are just studying. They are still studying. Doesn't mean that they are very young, but they are still studying. They want to make their way with it. Okay, so it's pretty new, so that means that you have to have a team around in order to make something that can be productized, and this is where we are focusing on. Our vision about data science is something that can be psychologically, I'm really thinking about psychology here, in 2 different parts. So you have the enterprise that has very important processes that goes from test, acceptance, and production environment in order to be able to deploy something to be used in real. And there are the data scientists that are trying to discover things from the data. That means that these guys are trying things all the time. Really, literally trying, right? Okay, my screen is flicking sometimes apparently. Yeah. In order to do that without screwing the enterprise layer, so we tend to separate it a little bit in order to dedicate some data science setup for experiment. However, what is hard to understand by the enterprise is that actually those guys need the enterprise, the production data. If you give them samples, if you give them some random data, I mean, it's like shit in, shit out. Right? You cannot do gold with stones. So you have to take care that actually the production data have to be used, and then you have to respect the credentials and all these things, of course. But this is very crucial. Otherwise, the models you're gonna deploy for weeks or months before you discover that just crappy, will probably lead your business. So you have to use the data from the production. So we have this focus, and then we bring this kind of data science platform that has all the fancy names, all the buzzwords that you want to have there. They are there, right? So in order to play around with the data. As you can see, I am a Mesos fan, so we use a lot of Mesos. and Marathon and Chronos, but it doesn't mean that we are sticking with Mesos. Why? Because there are a lot of enterprises that already bought some platforms already, and of course they pick Cloudera, AutonomWorks, or maybe sometimes Matter. So how to go with that? How to allow a data science team to work with the data and afterwards being able to pull back what they've done in the classical enterprise processes. There is nothing wrong in both sides, right? So it's very important to have this process in place, right? So what do we do in Kensu is that we take care of that, but for Scala right now. As I said, we are 11, so we are not able to do everything at once. So who knows the Spark notebook? Who knows about it? A few of you, so it's a tool that I created. And actually, it's only for Scala and Spark. Why? Because I want to do something thin, but straight to the end. And then I open the doors. In here, so what we do is that we take care of, at first Scala, opening a few doors, and then we will take care of that. But what do? Is that we take the data science work from notebooks, for instance, and we put it into enterprise production line. How do? We have a single, does it work? We have a one-click deployment tool that allows you to, from a notebook, to push everything in production, or at least generate something that they can be pushed into the test environment, then go to the acceptance environment, and then go to the production environment. That is a real job. This is how you want to deploy. You don't want to deploy a notebook, right? Who wants to deploy an IntelliJ code, right? I want to deploy IntelliJ. I want to deploy Eclipse. This has no sense, right? So you don't want to deploy a notebook. You want to deploy the real code behind it. But also, there is something which is forgotten, is that actually you generate data. The pipeline is just a sequence of different components which are all the time generating new data sets. And when we think about data set, this freaking intermediate data sets might be terabytes of data as well. So they are taking space on your platform. And if no one takes care of it, they just lost, take space, and no one can reuse them. That means that you have to have a way in order to expose them as relevant data. I'm only taking, and one good example is clean data, right? Everybody starts with crappy data, they clean it, and then they do the work. And this is like 85% of our time, right? Yeah, well, actually, we have to find the data first, because, of course, I'm never where we expect it to be. But okay, 90% of the time is finding the data, cleaning it, and then we do something. And I don't know if it's on purpose, but it's never really exposed as it. And that means that everybody has to start with the crappy data. It's like, I don't know, it's like when you're at school, you have to go through this, process in order to be accepted in the company. You have to do the crappy work all the time, even though it has been done already. So anyway, so the thing is, these pipelines are always seen as a freaking atomic thing. However, it's actually a bunch of different steps that are creating data that needs to be exposed in order to help the people around you. Also, the data platform that we are producing is extensible. I don't want people to be stuck with, I don't know, the implementation of random forest in Spark. I want people to be able to implement their own implementation of random tree, for instance, and then being able to apply it and still being able to deploy it in production, right? I don't want to have them calling us, hey, dude, can you implement our stuff because we need it in production? I don't want that. I want them to be able to extend the whole platform with their own libraries. So it's very something that we are taking care. And this is the thing that I'm proud of, the graph. So I'm a graph freak, so now it's known. I've done a lot of graph theory. I like it. It might be a bad side of my how to say, behavior, let's say. But I like graph anyway. So what do we do when the data scientist is working? We register whatever it does. So we tend to track what are his actions. What does he do with the data? What kind of model? What does he output? Right? Where? When? Why? Right? And this is exactly what data lineage is. So you know what is the input, you know what is the output, even though if it's recurrent, even though if it's a random path. The thing that I hate the most is like, where do I put my data? I don't give a shit, put it wherever you like. I mean, the thing is that it has to be searchable. You have to be able to look at it when it's needed, right? So the path is not something you have to take care. I mean, it's like bookmarks. Who likes bookmarks in a tree organization? Who used that? No one. A tree is not a good way to represent your mind, right? A good way to represent your mind is a graph, but it's hard to search it, right? Unless you use your neurons, but we don't know how it works. So, right, so the data lineage allows you to track what are the dependencies between data and the outputs. Also, data statistics that we are gathering live allows us to be able to say if there are differences between two data sets at some point in time, if the pattern is changed, or something weird happened, like a dummy test in Volkswagen, for instance. Automatic pipeline. I'm going to go fast and faster on this slide in order to move to the demonstration. Automatic pipeline is our way to be able to connect two notebooks together automatically based on path, but it's really crappy to connect notebooks on path. What is very important to connect is to connect the output, not the path of one notebook, to the input of another notebook, so that the outputs can change, right? But the other notebook will be able to track the changes, and then it will still be able to use the latest data. User awareness. Okay, so we know who does what, when, and why. Why? That means that we're actually doing some NLP on the notebook, so that we can discover that actually this dude is actually creating some insight on the next best action. For instance, if you do some marketing or what I don't know, churn or I don't know. We discover what it does. Runtime and awareness. So there's something that we don't have yet, but we are working on it in order to be able to discover that one guy is using a service and at what time, and if the service is responding fine and so on. Oh, by the way, what is a service? What is a service in data science? So a service for us is something which is giving away to the other people to access some data without even knowing where it is, right, and what it is. I just want to consume this data. I don't care where it stands to, where it has been stored, and how to access to it. I just want to have a service, and then I'm putting in some information from there. I don't give a, how it has been stored. It allows you to shift the storage engine behind the service. And this is why we have these microservices now as an architecture that allows us to, to expose each data set in the infrastructure with a single service. So you can say, I want this data, give me 1,000 of these instances. And it has to work whether the data is in Cassandra or Parquet. It has to work the same way because nothing prevents you to change the way you store the data. Why? I can use MySQL now, and maybe in 2 years I will have to switch to Cassandra. Doesn't mean that I have to change my front end. No, you have to use a microservice in order to access this data. OpenSDK, this graph is actually open, so you can publish your stuff as well. So if you have your own graph, you can publish into it. Efficiency catalyzer, I like this thing. This is where the graphics is whole importance in the software. With this graph, we are able to discover what data can be used for someone. Someone is working with some analysis. I don't know, maybe he's discovering, he tries to discover how many tiles he will sell next year. And the graph can tell him, okay, actually, this man worked on some process for last year or 10 years ago. Pretty much the same thing with this data. Maybe you can take a look at the data recommendation, or the model recommendation, or maybe you can ask the guy what he did 10 years ago. Because we tend to forget that people in the team are not long-lived, that they will leave, they will have another job, and they will leave with a lot of information. If you don't have information in somewhere, then you lose it, whatever happens. Quality monitoring. Oh yeah, actually we are gathering all the information. So we know how many lines we have in the data set that's been generated. We know how many partitions. We have information about different statistics on each column of the data set. That means that we can discover if there are differences in the quality of the data before we apply models. So we can discover that kind of things. And based on this information that can be on the data or the model, we can do some root cause analysis, like say, actually, I have a higher score on the data that has probably changed way more than the model has to change. Actually, the model dropped off in accuracy because the part of the data which was initially collected have changed quite a lot. So the model is still accurate, whatever. Random forest is okay, but the intermediate data is missing some information, some patterns. So it's very, very hard to get all the patterns in some data, especially when you do dimension reduction, of course. And if you do anomaly detection, you know that actually it's pretty much impossible. But anyway, so we can do this kind of information thanks to the information that actually we can pipeline everything together without asking the people to do it manually if requested. We can analyze this and more. So actually, it's the sky is the limit with this kind of graph. Okay, demo. I probably took too much now. Okay, the demo, yeah.
You want to give a 5 minutes break or you want to stay?
I don't know. There are still beers?
You guys have
Oh yeah, I'm for Belgium, so I drink beers all the time. So. I don't know, do you want 5 minutes break or? No. Okay, so you should have proposed that just right before the demo because, you know, no, we are listening to this guy for 20 minutes now, so we want a demo. Anyway, so this is the company. So anyway, this is the spy notebook. For who doesn't know it, it's a kind of Jupyter server, but fully in Scala. JVM, let's say. So I have a Mesos cluster. I can't see my fingers anymore. I had like 4 drinks already, so I can. No, it's okay. So I have a Mesos cluster with 3 small nodes, not so heavy. So I'm not going to do some fancy big data analysis anyway. So this is the HDFS. I have Chronos and Marathon. Everybody knows what is Mesos, Chronos, and Marathon? Okay, I don't see anything now. So, who knows Chronos? You have to shout, actually. So who knows Chronos? Okay, no one. No one, or are you shy? I don't get it. Okay, Mesos. Mesos is like yarn, but better. Sorry, it's not fair. No, actually, Mesos is a scheduler. So, so it's mainly. I'm going to ask for Chronos and Marathon afterwards. So, Mesos is a scheduler that allows you to deal with the resources in your cluster, and then you can launch whatever you like. Right? It's not. It doesn't have to be distributed. Right? You can launch basically a WordPress. Right? Mainly you can deploy whatever you like services, like HDFS, like Cassandra, like Kafka, like Spark, whatever. Marathon, you know Marathon? If you don't know Mesos, probably no. Okay, Marathon is something that allows you to ask Mesos to run something long-lived. So if this guy dies, Marathon takes care of it and redeploys it elsewhere if necessary, right? Okay. Chronos is something that does pretty much the same thing, but actually it makes it recurring, right? So you have a job that you want to run every hour, then it takes care that it's gonna run every hour. Of course, if it fails like 3 or 4 times, then it's gonna stop, right? Then there is something wrong happening. Then you need some monitoring. But actually, this is what it does. So it tries to run the job and with some strategies in order to rerun it or whatever. So Mesos, Marathon, Chronos. The spy notebook. So I have a few notebooks. Initially, I had planned to do a bit of live coding. Do you want me to do a little bit of live coding? I know if you want to with Scala and Spark, manipulation. Oh, damn it. It's fake, right? No. Milano. So actually, what I'm trying to do now is I have a very small data set in order to speed up the demo. But In this data set, I have Yahoo quotes, information about stock prices for a few stocks. In a crappy CSV, of course, CSV, right? What else? So it's a bunch of strings separated by commas that I have to process, and this data is on HDFS. And what you see here is a notebook. The notebook in the enterprise version has Git access, so you see that it has one commit already there. So it means that if I go there, I should have a new file called Milano, and this is my notebook. That means that every 2 minutes, this dude is gonna publish a new version of this notebook unless I flag with a version of my own. Like I can create a SQL context new IG. Boom. If I save it, then normally it should have changed now, and it contains my code. There we go. Right. So that means that this guy is backed by Git, GitHub, GitLab, GitLib, whatever.
Yes, can you make the font a little bit bigger?
Yeah, I can. Yes, I can. Like that is okay? Okay. So now I really have to type and shut down my automatic typing. No, so actually there is this thing there that shows me the auto saving, but I can flag as well with my own version. If I flag like that and then test and then boom, I should have my, damn it. If I go back there at some point, I should have there. Did I? I didn't save it. Yeah, I didn't change it. That's why. Import. Damn it. Import SQL context. Implicits. I can import as well org Apache. Spark, SQL function for the fancy things, and then I can flag it with, I don't know, SQL. And normally here now, I should have my SQL commit here. So, well, okay, so now I just set it up. I just imported all the SQL things. So SQL is very nice. The SQL is the wrong word, though. Actually, what we should have there in terms of SQL is relational algebra, because this is what we are really interested in. I know if you know relational algebra, I guess yes. Who doesn't know about relational algebra? Synca, Pi. So relational algebra is what is behind SQL. just some mathematical algebra that allows you to have logical meaning about or thinking about databases. Now, it's very, yeah, that's my mathematician side that is raising up. But anyway, it's something very strong that you cannot fake behind it. It's like ggplot. Who knows ggplot? Right, ggplot is an algebra but for plotting. Rational algebra is an algebra for tables somehow. Okay, so I have my SQL context. I have imported all the implicits or whatever, so I should be able to read some CSV from HDFS. So it's I'm going to read some. No problem. Some CSV which is in HDFS. Okay, so I know it by heart, and I think it's that one. This is the thing that takes like 80% of the time to know that is actually the path, right? I know it by heart if it works, but actually generally we say, hey, do you have codes data? I don't know. Look in the database. There is no database about data generally. There is database about observations, but not about data sets. And this is something really missing. SQL. So it doesn't exist. Leader one abra de la fe last 9,000. Yeah, and no, Nust is not looking good actually. Of course, I'm missing the .com. So it's a CSV string. Oh, beautiful. So if I take a few of them, like 5, I have my beautiful strings. Okay, it's distributed, it takes a little bit of time, but you see that we have basically a value, which is a string separated by values. So that means that I can take them out, sorry, CSV, and I can map. And on here, I'm going to split. So this is just a one unary function that takes one argument and I split over it. But since I'm very lazy, I'm just using the underscore in order to replace the lambda x colon x dot split, right? For Python, or x dash arrow, fat arrow, x split. So this results into a, sorry about that. I remember that I have to go to RDD, and then I have here to take get as, boom, boom. I'm just showing that actually we can take some fields out of the result that we have. So, sorry. So actually, we have a row that contains one value, which is a value name. So from the row, I get the value field out of it. I say that it's a string, and then I split the strings by comma. I end up with this RDD of string. And actually, I have 3 values. That means that I want to do something which I love in Scala, by the way. It's do some pattern matching. You know about pattern matching? Okay, case, array, and then the first is stock. The second is date. The third is price, and I'm going to return the stock, the date, and the price as a double. Okay, it's a RDD of string, string double, and I want it to have names, so to df, and then I pass the state stock name, no, not stocks, but stock, timestamp, let's say, and price. And now I have something which is a schema. I like schema because it has name, it has types. From there, we have something which is looking nice, but not enough, because the T has as a string type. So T has as a freaking string type. And string doesn't mean anything in the case of a date. So I want it to be a date. So in order to have a date, then you're going to that path, and you say, I take this data, and I'm going to convert my TS into a date. But before being able to convert to a date, because it does no time, I have to, I think it's 2, is it 2 Unix timestamp? No, Unix timestamp, yes. So I take S, TS here, so I convert my TS column, and I say, yeah, actually the format is YYY and M date. And I cast it as a timestamp. Okay, I don't like this API. Okay, it's all strings, I don't know what I'm doing. But anyway, it works. There is the dataset API, which is a little bit nicer, but not as nice as I want it. So actually here I'm converting the string to a date. So I have my date. So this is looking like something that I can expose to everybody. I didn't do anything but just parsing the information, and I don't want my buddies to do it, right? Unless you're a creepy. But anyway, so I don't want for them to do it. So what I want to do is that I want to expose this as a regular file, as a regular output. So I want to store it for someone else. So if you want to store it, then you can say that I want an output, and actually my output is going to be something like that, for instance. But damn it, actually this code CSV file can evolve, right? So that means that you might want to make it a little bit more, a little bit more flexible. So you can say, okay, system current time millis, and then you say it's a parquet. So you keep the schema. So here I want to save this information using a timestamp millis. That means that it's gonna, every time it's gonna run, it's gonna use the current time in milliseconds to create the path. That means that there is no freaking way to know where the data will be unless you know exactly at what time the job has run and generate the data, right? Which happens all the time, right? So more often even in streaming. But what you want to do is that at some point you say, okay, if it exists, maybe you want to overwrite. You overwrite. You want a parquet, and the variable that you want to save is with TS. And what happens there, I save it. Behind the scene, it saves for you the data. Okay? So it takes a little bit of time, unless I did some mess, but it takes a little bit of time in order to save the data, and at some point it discovers a few things which are interesting. Does it still have some memory for me? Yeah, it's still connected. That's good, unless I did something wrong there. Did I? There's something wrong happening. So this is one thing that I like to have there is actually I have all the errors happening in the cluster in my console, so I don't have to check the cluster. And there is something weird happening, but I know what it is, actually. I think so, by the way. There we go, okay. So it's just some timing problem. So now, what is interesting is that something has been created for us. If I go in the metadata of the cell, I open it, and I see that this guy knows what is the schema of the output. So it puts the fields in there. And also he says, actually, it's a data frame, it has a schema, but also we know that it has read this data there. So it detects that the data frame has read a few cells above this data set. That means that it can connect the random recreated data set with the original inputs. So we can have this kind of data lineage that I was talking about there. So what do you want to do from there? You want to deploy it. So there are a few extra steps that I'm going to talk now, but you want to deploy it, right? But before that, you want to have something relevant in order to do some discovery. So I can go back to the list here. I shut it down. I take my full example in order to speed up the process. And the full example takes the Yahoo's code, and it creates a nice matrix with it. And the matrix contains a timestamp. And for each timestamp, it creates an observation of each value of the stock, right? So if I go way below there, it shows the table. So what I do at some point after having created this nice data set, exposing it as a output, I can select the timestamp. No, this is just for showing it. This is a plot. I can group by timestamp pivot on the stock and then sum the price. This is just a way to transpose the data, right? So you say group by timestamp, there is one value per stock, right? Pivot on the stock, and then you sum. But I could have taken minimum, maximum, sum, median, whatever. There is only one value, so we don't care, right? Just a way to pivot the data. And then at some point, you end up with this kind of data. You have a timestamp and a few values per column. You can plot something, and afterwards, what you say is that, okay, I'm going to save it. But there is something different there. See, the HDFS path is not provided. It's a variable. Yeah, because actually this cell is actually the Scala code, and this HDFS variable is in the metadata, and it's a custom var. The interest with this custom var is that this guy will be exposed as a parameter of the job when it's going to be published. So if you want to deploy in another environment, you just change in your application.conf the path to HDFS, and it's going to be fine. It's going to be able to access other environment, but just your local setup. So this is a good way to expose some configuration out of the way, and you can put it there directly in the custom vars, and these things can be even created at the server level. So you're gonna have a bunch of different variables, so even for everybody is gonna be there. So that means that this HDFS root can be used there as a regular variable, and then you attach a concat a few information in order to save the new table, the new time series in Parquet with a random name. So in order to be able to use that now in production, so you're gonna ask someone, okay, so now that I have this notebook, can I deploy it somewhere? Yeah, actually, we have to take the notebook and then we have to transfer everything into a RIP package. We have to create the dependencies to create a, I don't know, maybe a jar, and then maybe also a Debian or also a Docker. And at some point, it's going to end up in the production after the test and acceptance checkups. What we do is that a little bit different, just a little bit different. We go there back and then we click on deploy job. We give it a package. I'm gonna explain that afterwards. I say, okay, I want it to run every hour because it's pretty good. I can run it every 5 minutes if I like, but every hour I know that the code CSV file is gonna change, and I want to have a specific path, and then I'm going to create the jobs and the services because there are two outputs. I want to be able to provide the other guys a way to access the original data that's been cleaned and the time series matrix. So I want to have both services exposed. So if I click on deploy, what happens? What happens is that behind the scene, we create real SVT projects that can be checked, that can be pushed into Jenkins, they can be tested, they can be extended, right? And what do? They generate some Scala code, okay, but also they contains all the libraries that are used in the notebook so that they can be used also offline, right? So you don't rely on any other, I don't know, Sonotype or other repository. Also, we are taking care of computing the statistics. So we generate the file, but also we compute a few statistics and we publish into a graph. We also register who did what. We register that the guys, I'm connected as demo now, but I can connect with other users, has actually generated the job. So that means that his credentials are following the job. That means that in production, they cannot use something that this guy cannot use. That you have to deal with in enterprise. And for good, right? I'm not chewing on that, but I mean it's very important. What does it do as well? I mean, it generates a Debian package automatically, and this Debian package can be pulled by a Docker image and it can be put into Kronos. Okay, so we generate the Kronos.json file as well, so it publishes on Kronos, so you can run it from there. So this whole thing that takes, like, by experience, a month, right, in order to have something that is good, because I'm going to show afterwards the code that does that, right? I mean, you can pull your hair off, because this is very, very boring, and it's plenty of boilerplate. So, and this is only for the job. I'm not even talking about the services. You've seen that the data frame has some schema. So why the heck would I use JSON? Who likes JSON here? Okay, so you're hand. There was second one, maybe. Okay, there are a few reasons why I hate it. There is no type string. Okay, that doesn't mean that it's worthless. I mean that there are other ways to represent data, and JSON is a good way to share it with other kind of human brain, if you like. But I mean, at some point, you can have an intermediate way to share the data that can have at least schema and a binary protocol. So that's what you do. Actually, from the data frame schema, we generate an Avro schema. You know Avro? Who knows Avro? Okay, a few. So Avro is like so. Who knows soap? A few less. Soap is like, there's nothing like soap, sorry. There's something that dates for the 90s and then the 2000s. There's a good way to share information between machines. It was XML based. Yeah, it was XML based. And this is what kills it. Because it's XML, right? So this is why we created JSON. So it's XML based, but there is something great about the SOAP that we lost with REST and JSON is the capacity to be able to detect what the service is actually currently being able to do. So you can contact a service and say, who are you? What can you do? So there is no freaking way unless you respect some kind of esoteric specification in REST to allow you to know exactly what are the methods available on a service, what is its version, what are the inputs types, what are the outputs types, right? This is what Avro is offering me, a way to expose my services with a clear protocol, and not only in the inputs and outputs, but also at the method level. And this is what we are doing. We convert the Parquet into Avro, and we are working on Cassandra to Avro, Kafka of Avro. This is simple because they already deal with that. Or whatever, Elasticsearch or whatever, in order to be able to have something very neat in between. So if I go into this projects tab, I should be able to see what's going on there. And actually, it has already created the package. And I should have something in Kronos now. Boom, I have my job there. Zoom in. Yeah, it has also a zoom option. Actually, I have it. I could run it. But before that, I can go there and see, oh, yeah, it starts something else. This is the service. So now it creates the Avro files, so the description of both outputs. It generates a service that can be deployed on the cluster automatically on what Marathon, right? As a Debian, as a Docker, blah, blah, blah. And the service will tell a grab, and I'm going to show soon, okay, I'm deployed on that one on that port. This is what it generates. And by the way, since I have Avro, I can generate a library, a Java library, a JVM library, that can access the service and will provide some schema-oriented protocol to access this Parquet file. That means that if you use this library that accesses the service, that accesses the data, the only thing that you want to know when you're a user, that you want to use the data. You don't care where is the data, you don't even care where is the service, because the client can ask the graph, hey, where is the last service deployed? Okay, thank you, here is the port and the host. Okay, hey, service, where is the last data set that has been generated for this output? Okay, this is the path right now. So the only thing that you care about is that you want to consume the data, not where it is and how it has been deployed. Something very important. It means that you are completely decoupled from the fact that it's actually under Parquet and it's random. So, boom, and at some point the second one is starting, and it's also generating some information, and again it's generating all the relevant information for the service. Something important with services. The important fact with microservices is that you can scale it. You can scale it horizontally. If you're a Cassandra, right, having a way in between your code and the Cassandra table in order to scale it horizontally is pretty neat. This is all the purpose of microservices again. So if you are able to detect that one service is upon a pretty strong load, then being able to scale it horizontally is a good way to solve a lot of different problems that you will encounter in production. So the service allows that as well. There's nothing new, of course, but I mean, being able to deploy it automatically is pretty neat. And we are reaching the end now. So I'm trying to fill the blanks right now, right? So I know it takes time for the first time, so I'm filling the blank. And I know that I'm pretty much at the end. And the thing is that it will happen in there. So it's a git blit. I don't know if you know git blit. If you don't, I'm not going to. To be upset because it's not that good, by the way. But it's just a Git server, right? It's not GitHub. The interest here is to show that any Git protocol is fine, and at some point the code has been generated is going to be available there automatically. Just with one click, a few words typed to customize the way you want to deploy it, and then it's going to happen there. And actually, so here we are creating the Debian file. See? I don't know if you see it, by the way, but so we are generating a Debian file here, and the Debian file will be published, and the Docker will be able to put it. Sorry. Yes, I didn't change that. That's why it's checking only 10 seconds. It's going to change every second. Something else that I want to show as well is that there's something interesting to have is that when you have your enterprise layer in Yarn, for instance, and you want to use Mesos because you are happy with that, you still have to cope with the fact that you have to deploy some Yarn processes. And there are a few ways to do it. Configuration is a good way to do it. I'm going to show how to do it. The other way is to publish a jar, and you say, okay, you have the jar, so do whatever you have to do with it, right? And this is why we have also integration with other, whatever Artifactory or Sonatype or whatsoever, and everything which is built is also published into this repository. So if you go here, you can see that actually there are a few jars that have been published only even for the job, and afterwards we'll have also for the services. So if you want to use the library, okay, you connect to the Artifactory and you start fetching the libraries, and then you will be able to use the library. If you want to publish your service, your job using Spark Summit, if you're very afraid of Spark Summit, you can do it because the jar is also published somewhere. So you don't have to take care of all these marathon or Kronos things if you don't want to. You can still use the internal tools that are provided using Spark. So everything is in there, so you don't have to take care of everything. And at some point, if I do that, maybe I will be, I'm lucky, Export Stock is there, I have my job, and see the library have been published into its own folder. That means that I'm totally offline. I can build this thing without being connecting to internet. I have my source main, which contains the application.conf, which contains my HDFS route that I can change if I like to another environment. I have my Adobe UI that I'm going to show, which is my graph. I have my class path that I can change, the number of cores, everything can be configured from there, and then you can publish another version of it. Something else, the Kronos, the JSON that has published it, of course, but also, of course, the Scala code, which contains a few metadata about the job, but also all the fancy thing that you have to do in order to be able to deploy the things. And as you can see there, every cell is decomposed. And what we are going to do by next year is to create some metadata around each cell in order to be able to catch what's going to happen in production when this thing's going to be deployed. And also, we are creating a few statistics. Now comes the statistics. I go back to the Kronos, I say, hey, can you run it? Fine. And at some point in this visualization, you can see here, this is the job that I've just deployed. I'm demo. I created some code which is connected to this Explore Stock, which is a notebook. It writes some code CSV file. It's used in the code. It outputs 2 Pocket files, which one of them has one service is connected to it. Apparently, there is one which is not going well, so I can maybe restart it. So which one is this? Oh, by the way, I have the schema of this Pocket there. The variable is with TS, and maybe with TS, which is the first that I've created, I can go back in Marathon. I increase a little bit. Marathon, I should have these 2 services there, right? The services have been generated and published, so they are happy. They are starting. Maybe one is not very, very good, so I can suspend it. I can say, okay, actually, I shut it down, and I scale it when it's going to be shut down. I scale it by 1, and this is the kernel that I shut down. Boom, here, to this Parquet file should be attached a new service at some point. Not yet. So it's starting. Where is it? There. There we go. So I have the second one there. So it starts and it publishes. Okay, I'm there. Service worker 1. Here is my port. Okay, now you start using. You can start using me, and then I'm going to take care of reading this data set. Oh wait, by the way, Parquet has no data set yet. You all right? Yes, actually it has one. This tux thing there is a data set that has been generated. And if I go to his page, I can see a few things like the number of partitions, the number of rows, and a few information about the columns that are interesting to check, like the price. All right, I mean, I can go back for one step and moment in the graph, and I can check again the code, explode stock there, because remember, it had two outputs. It's not the one that I want to check. The first one is there. Boom. The schema is a little bit more elaborated because this is the matrix. It has some data, and this guy has a little bit more partition. It has 200 because it uses a little bit more data frame than the others. And all around, you see all around, this is just fake right now. But this is showing what we are working on. Like this data set is used for that and that. It's similar to this code or this data set because it has been used by this guy or by this code for the same kind of things. The data has this kind of coverage there because actually only these columns have been used in processes. Or these rows because the filter has removed so many rows out of the data set initially computed. So all this information is showing the data coverage of the data. Like test coverage, how many times this function has been used in code, right? It's the same thing with data. Why wouldn't it be interesting for us to know this information? Maybe there is one column which is not used anymore, and maybe there is information which is lost and not used by the company. And when you are a data-driven company, missing some information in the data is very painful. And again, what are the top features? Who use that? And so on and so forth. So this is all information that are collected automatically for you because you have used something which is filling all the gaps, which are the boilerplates in order to download to upload your code into production. And I'm not done yet. I have very few things now. So from this code now, you see though there is this graph. We might want to. It's very crappy. So I mean, I know it's crappy, but we don't care, right? Because at some point we want to go there and we say, do you have information about IBM? Oh yeah, actually there is a time series thing that is talking about IBM and also this code. So you can go to the time series and say, actually, yes, there is a column named IBM. This is what you're talking about that. Okay, fine. So this graph is just, yeah, because I like graph. I asked for it. But anyway, it's not really useful. This search interface is the most important thing in this part. Although, what is the next thing that we are working on now is that we want people to not go there anymore and to use some kind of code interface like a notebook or in the future some IDEs, I don't care. And the connectors are able to say, okay, actually this data set is interesting for you because actually you are computing this initial data set called CSV. It has been cleaned 2 times. It's available, so just use that one. So recommendation is the way we want to do instead of having people searching into the interface. And now, to finish it, I can go there to this guy and show how we can create a small model about it. So we have this table, right, this matrix. The timestamp, we're gonna put it apart, right? So we don't give it any attention about this timestamp. I will take care of this table of data per stock. What we are going to try to do is to predict IBM stock based on the others. And to do that, since we are pretty lazy, we're going to do a linear regression. Okay? So in order to do that, I'm going to consume the data initially. It's not the right one. why the heck is it going further? So this is the one I wanted to open. So in order to do that, so I mean, it's pretty simple. We just have to create a feature out of the stock information, and then from there we just run a random linear regression with a few hyperparameters, fixed totally randomly, to be honest. And the thing that we are currently doing, but it's not going to last forever, is that right now we have to connect manually to the graph in order to fetch what is the last version of the data for dedicated output. And this is something that can be integrated into this panel there. See, the search analog, I'm not going to show it because of the way it's through my demos. Actually, if you search in it, then it presents a list of results, and with a plus sign, if you click on the plus sign, then it adds this link to other notebooks, or it presents a snippet of code that can load data, or that can load a library, or that can load a data set or service or whatever. So this integration is the way to do it afterwards. And now this is the Cowboy way, and it's going to be this way. So here, I'm just connected to the graph, and I say, okay, for this notebook, this variable, what is the last path? And this guy is returning this, returning me this information there, which is the last path. I'm going to go fast now. I'm reading the last location. I'm removing out of the feature set timestamp and IBM because IBM is my label. I create a vector assembler that assembles all the names into a feature array of doubles. See where? There. This is my names into my vector assembler. So I assemble the data. I, of course, random split my data in order to have a small test data for afterwards. I'm creating a linear regression, setting a few hyperparameters completely randomized. I didn't do some cross-validation or whatever. You can do grid search, you can do whatever k-fold you have in mind, you can do it there, but I didn't do it for simplicity. I didn't run that guy. Should be okay now. Well, now it fits the data set. That means it creates a model. There. And now this is the hard part, because actually, besides the coefficient that we can pull out of the model, I'm not going to show it. Actually, the bar that you see there is just showing the Spark job running, and you see it flicking, up and down like in Windows, because actually these are all the runs that it does. Coefficient, intercept, summary, blah, blah, blah. You can do some task prediction by providing this data. You can compute the RSME. And afterwards, you want to say, okay, now I'm very happy about this model. I want to deploy it somewhere like that. And my model is LR model. It's a linear regression. It's just an handler. This is something that allows you to extend the way you like it. So you can put my own handler there, just an ID into the model handler service that allows you to tell the system how to save, load, predict using a model, or how to compute statistics about the model, metrics, sorry, about the model. So this is the way to configure the way you want to deal with your model. That means that you can put whatever you like, whatever libraries you like in there, DL4J, H2O, your own, or whatever, you can deal with it without any problem. And what's interesting, if I run this guy there, I can also show, of course, the metadata. And if I look into the metadata, it sees that actually this guy is using this archive. It's a linear regression model, right? And this is impossible, I tell you, impossible without doing Scala code parsing or REPL, because there is no way to reconcile a model with the initial data set. Why? It's simple. A model is a POJO. Who knows a POJO? Everybody knows what is a POJO? Not everybody? Okay. Not everybody maybe. A POJO is this from Java. It's Java object. Plain old Java. Plain old. Yeah, there is the old that I didn't want it to. Okay. So just a way to package your data into a class and save it. Yeah, pretty much DAO and things like that. So that means that you cannot have references to the initial data set the way this guy will summarize the whole work, right? So it's a POJO. It has weak references. So this guy has no way to be linked to the other. That means that I'm doing here, the secret sauce is that I'm doing JavaScript foo here in order to detect what is the link between our model and the other data set. And by the way, you know, I mean, yeah. So from there, we can know what is the input so we can deploy it, right? So we can go back there. I'm gonna deploy it. Dude, stock, one hour as well. And I'm going to deploy the service because it might take too long. Okay, shut it down, free some resources, and now I have a second project that I started, which is publishing the job. Meanwhile, so this guy is also building this fracking job that is using the data, but it's always connected to the last ones. Something else, it's also computing a few statistics like the RSME automatically, R2 for this one particularly, right? What is it computing as well? I think it as well contain explained variance. A few statistics about the random regression model in order to be able to, discriminate from another, right? So just statistics, but it can be extended by the model handler service, by the way. But by default, it contains a few things. And this is exposed in the graph. And if you have this model built every hour, at some point you can have this time series of model that allows you to see how the model is performing. And at some point, if you see a drop off accuracy, then you can start looking at the data or the models or whatever in order to detect where is the what is the culprit? Who is the culprit? Like the data, the code which is analyzing, maybe the time format that I put there is not accurate anymore. Maybe it changed somehow because someone decided to put the date in it, for instance, and then it screws. But the code is still passing because it just gets rid of this data, and then afterwards you miss a lot of data, and then your model is dropping off accuracy like crazy. So the job is currently building, just increasing the check. So okay, really the Debian is the longest part actually. Why? Because it's like 600 megabytes each. Of course, all the Spark libraries, and that's it. Only even that, I mean, it has a lot of them libraries in there. So it's building a full package that can be deployed at once. So that means that it can be very big. And we are currently optimizing that in order to speed up the process by extracting all the libraries of Spark into a dedicated environment though. Boom, so it's published to analog UI, and then at some point I go back there, I look at the vis, and I have my notebook connected. So I have my new notebook there that is building a model there that is published, and it's linked to my IBM. That means that if I go back there, I have another job that can run, and this guy is going to run what on the data that has been published. If I run the previous job another time, it's gonna tick to the new data set, it's gonna run the model onto this one. But what is interesting is that also it publishes the matrix. That's why I'm running it right now. So we will have both the model attached to this red node there. We'll have the model attached to it, and also we have extra information about it, like, as I said, the explained variance, I think, and so on. So if I go back there, it's running. So it's starting there on Mesos. And it's very fast, so boom. There I started the other one as well. Anyway, so we see that, okay, so we still have 34 CPUs, it's fine. And at some point, it's done. I go back there. and I have my code there, which is attached to this model, and I have my IBM model there. And it's not well presented there because it hasn't been integrated into the page, but we have the RSME here, which is 8.9, exponent variance 82, R2 is this, actually this one is not well presented, by the way. The input, so the input is interesting because then you know exactly what is the format expected by the model. So you take the data set, you format it in a certain way, and then you pass it to the model so you can train on it. And also, we know what is the prediction column that's going to be created. So when the service is accessing the model, it fits on the new data set, and then it knows how to fit the prediction out of the results. And the label column is for the training, by the way, and the features column is how to package the information and input as a feature. So everything is in there. That means that we can track how this information is evolving time to time. So that when you use the model, always you will have the last version of it. And if we go back to this to close that, is it the one? I think this one. 3, we should have another one, which is learn, library, main, Scala, app, and we have it there. And from there, I'm going to stop it there because otherwise I won't take too much time. But from there, you can, of course, take the model, predict on it, and create another service, and the story in the very hands, right? So, you close one small pipeline, but this pipeline can be seen as a part of a very big pipeline, and so on and so forth. It's like Russian puppets, no, but you got it right. I can't remember the name of this thing. Matryoshka, thank you. And just to be sure, okay, they are there, so everything is there. And by the way, if you want to play a little bit with this kind of tool, which is in our company, there is this training that we do with O'Reilly, which is about Kafka and Spark and Cassandra, because Kafka and Cassandra are the other part that we're going to handle next. So we had Parquet, we had Marble, comes Kafka, comes Cassandra, comes Elasticsearch, comes Clodian, and so on. And in this pipeline training that we give O'Reilly, we go from this kind of Yahoo codes that goes into Kafka, training to start read into Spark streaming, goes into Cassandra. There is a model which is trained on the Cassandra table, and then you have a service which is built on top of it. But everything is manually done, not like there, right? And at the end of the training, we gave some beta access code to a cluster. So we offer a cluster of a few nodes, a beta access code, so you can play a little bit with the tool, by the way. And yeah, actually, so there is this book that we are currently writing. By the way, this book, I like to say it because this book is fully created with a Span notebook. So this book will have notebooks beside it, and the notebooks will generate the book. And actually, you can replay the whole book using the notebooks. There's a lot of book in my phone. But actually, I like this kind of chaotic, kind of recursive thinking. And that's it, right? So if you want to reach me out, so feel free. A few information there. So the demo was pretty long, I told you. There's some pizza. I don't know if there's still some pizza there. Stay tuned on Twitter, Kensu.io. So there's some demo access especially for already training initially. We're still hiring and told about it. Please contact us. And if there are still questions, I'm open to them, especially with the beer. But now it's okay as well. I don't know if John Mario, but he didn't listen to me. Well, yes? No, Q&A. So are there any questions about whatever, the product, Spark? I don't know. It's time to shoot, or you wait for the beers. I mean, I'm open to anything. There are never questions. I'm okay with that. Certainly at 9:15. Okay, I'm fine. Thanks.
I have just a question for the service. Can you spend some more word about how the service? So because I saw that the data are backed to HTML and Markdown format, but then the service exposed that using Avro, and so you're supposing. So what's the point on creating a service to serve the data? So you suppose there can be something that replaces like an API that can be used to connect to WebUI or something like that. So it's not really very clear.
So think about a web application, or Tableau, or ClickView, or whatever. If you don't have this kind of an intermediate layer, then you have to create a connector across all different storage that you want to have, right? And you have to say to the guy, okay, the data is this for Cassandra, this key space, this table. And at some point, right, you leave the company. So when a guy enters the company, says, okay, Cassandra is a piece of shit for this data, I'm going to store it elsewhere, like in Redis, I don't care, right? What you do, you are actually removing this data out of the hands of the other guy, right? Because you switched from another one. And at some point, it will come to you and say, hey, actually, where is the data? I put it in the Redis, but I don't have connector for Redis. So, okay, let's run connector to Redis and so on and so forth. So that's one thing, right? So you you segregate the responsibilities. The other thing is to scale horizontally, right? If you access like crazy on parking, you might have a problem. While a service can also help in organizing the different requests and things like that. If you want to put some logistic there, cache as well. If you think about Aluxio, do you know about Aluxio a little bit?
Yeah.
Aluxio, right? Aluxio is the new name for Tachyon. It's a very neat tool in order to put some cache. And I like to say cache in time and location, right? That means that it's pretty like query mining. You know query mining, right? So it's like caching the result of some certain queries, right? This is the way Google optimizes its query services. If you do this kind of reflection, then the data is going to be accessed most probably at some point of time. The probability to access a certain data in a data set is very high, separated in time, and it will decrease probably exponentially inversely with the time. That means that you can cache a part of the data into the service without having to access all the time to Parquet, for instance. Because accessing to Parquet, especially in the long row, can take a lot of resources. Now, a few things that you can do in this layer, also you can put these services into the L2 layer while everything is in L3. You can have some extra logic like user credentials and so on that can be put in the service, while it might not be the case in the storage engine and so on, right? See, so there are a lot of things that we can expose there. It's all about enterprise, right? So if you do your thing in your corner at home, you don't care, right? But when you have to deal with this kind of problems, then you have to take care of that. Also, with this kind of representation, which is an Avro. This is the Avro for the model that I've shown before, right? It's very simple. This Avro AVDL that generates the code behind the scene. Then you have to have only one connector. To whatever tool you want to use, you have one connector, which is Avro, because this guy can understand that, but also he can also understand the methods. And the method exposes the way you can use the service. You connect to the service, say, hey, what can you do? Just code. So you receive this kind of thing. Actually, I'm able to take a service request here, which is the name of the method is list. I take a server request. The service request is only enough certain limit. And it returns the service response. And the service response is just packaging some domains and object and domains. This is the thing that I just showed before. And this is just something that I can generate easily because it has no sense somehow, right? But if you want to extend this code, the server with extra method, and you want to expose this IDVM, you can do it. You can do it in another separated file that I won't touch when you generate the code again, and then you can put some extra method in there. But at least, whatever, I know that I'm talking a lot, but at least when you go back there and you look in the server, the source main, everything that you have in your server is all code there, which is plenty of boilerplate. It's just 99% of this code is just boilerplate that allows you to connect to Spark, to read from Spark, to connect, to convert your data, which is in Spark, into Ever, and so on and so forth. So you don't have to write it, because you just extend with your business logic, which is doing some query in Parquet, filtering of columns, and then you just have all the access to the right data at any time. There's a bunch of reasons why you should go into the service. But doesn't mean that if you want to do exploration, you should use a service. Definitely not. Right? Then you go to a notebook and then you read the data and you connect to the output of the notebook, of course. Right? It's different.
So each notebook, the output of each notebook is just a RPC method.
So the outputs of a notebook can be exposed as an RPC endpoint, but also it's going to be published into the graph as a regular path with their own metrics. So it's very separated. You have the, let's say, you have the data mingling thing that is path and metadata, and the other which is data usage, which is service. It's very separated, but in between there is something which is common. Is it okay?
Yeah.
Okay, cool. Thank you. Thank you.
So thank you very much to our international guest who traveled all the way from Belgium for us, just for us. Now you're going to Rome.
I'm going to Rome after it.
It's gonna do a Italy tour of conferences and
if only it
talks.
was true.
Gonna go back to Belgium with a headache.
With a belly like that because I'm eating too much here.
And I really need to say thank you to our person here. So we want to invite Alessandra, and thanks to her, we actually managed to have this event here in Pirelli. So she's.
By the way, this is probably one of my best events so far. I mean, the food was extraordinary, the room is fine. I mean, just perfect.
Thank you very much. And yeah, so I did the digital organization, but she did the actual logistic of everything here. So thank you again, both of you. Yeah, so we will publish the slides again, can we?
Yeah, there are 8 slides. So it's
Slides. So you're on YouTube, by the way, so you're already recorded. And so the bar is still open if you want to grab something to drink. I suggest to not stay too long because the guys, they also want to go home. But yeah, so if you want to stay a little bit just for a drink, then we can stay, say, 20, 30 minutes, no more. Let's not try to stay too long. If you want to stay longer, then we can move somewhere here around the area. Okay? And thank you very much for
Thanks, Internet.
That was amazing.